Now sir, let's go to the next concept. We have job sequencing problems. Job sequencing problems. What is meant by job sequencing problems, sir? Suppose we have to perform n number of jobs and 2 machines are available. Let's see this point one more time. Job sequencing problems means there are n number of jobs. For example, job 1, 2, 3, 4, 5, 6. 6 jobs are there. There are 2 machines A and B. There are 2 machines A and B given, sir. The processing order of the jobs is AB. The processing order of the jobs is AB means each job will enter into the machine A first, then it will go to machine B. What additional information is given to us? Processing time of these jobs are also given. Processing time of these jobs are also given to us. For example, processing time of job 1 on machine A is equal to 7 hours. On machine B is equal to 3 hours. It is 4 hours and 8 hours, 2 hours and 6 hours, 5 hours and 6 hours, 9 hours and 4 hours, 8 hours and 1 hour. This way, processing time of each job on each machine is also given. What I have to do here is how to reschedule these jobs in order to reduce the idle time on machine B and also to calculate the total elapsed time. Here our objective is what, sir? We have to calculate the total elapsed time. Means total hours required to complete all these jobs. And as we know, our jobs are entering into machine A first, then they'll go to machine B. Okay? How can I schedule this one? Before starting the actual concept, let us see here, when I process these jobs as it is. When I process these jobs as it is on these 2 machines, what will be the total time required and what will be the idle time on the machine 2? Okay, sir. As it is, I am processing the jobs. When I process the jobs as it is, this is machine A. At what time it is in and at what time it is out. This is machine B. At what time it is in and at what time it is out. Idle time on machine B. Idle time on machine B. Jobs we have 1, 2, 3, 4, 5, 6, sir. 6 jobs are there. Look at this, job number 1. At what time this job can enter into machine A, sir? As and when the work is assigned to you, you can start the processing. So 0 at the time, first job will enter into the machine number 1. First job will enter into the machine number 1 at 0 at the time. And to this starting time, you add the time required for processing this job. 0 plus 7 is equal to 7. 0 plus 7 is equal to 7. 7 hours this job will take for processing on machine A. So end of the 7th hour, it is coming out from this machine. As and when it comes out from machine A, immediately it will enter into machine B, sir. So at the end of the 7th hour, this job is processed on machine B. From machine B, how many hours this job is taking? 3 hours this job is taking. So this is 7 plus 3, 10 hours. At the end of the 10th hour, this job is coming out. This job is coming out from this machine. Okay, sir. Look at this here situation. As long as first job is processing on machine A, second machine has to sit idle. One more time I am repeating this point. When job number 1 I am processing on machine A, job 2 has to wait. Machine 2 has to wait. How many hours the machine 2 B is sitting idle? 7 hours the machine B is sitting idle. Therefore, idle time on machine B is equal to 7 hours. Idle time on machine B is equal to 7 hours. Now sir, go to the second job. At what time job 2 can enter into machine A? At what time job 2 can enter into machine A? Second job can enter at the end of 7th hour. Because machine A is free after processing job number 1 at the end of 7th hour. Okay. Job number 2 will take 4 hours. 7 plus 4, 11th hour. This machine is free from job number 2. 11th hour, this machine is free from job number 2. At this stage, sir, can I process this job on the second one immediately? Yes. How I am analyzed this one? Identified machine B is free from previous job at the end of 10th hour. Machine B is free from first job at the end of the 10th hour, and this machine is waiting 1 hour, or this machine has to wait 1 hour before it being involved with the second job. So machine B is accepting the second job at the end of 11th hour. And how many hours it will take, sir? 8 hours it will take. 11 plus 8 is 19 hours. So end of the 19th hour, machine B is free from job number 2. So from the end of 10th hour to end of the 11th hour, 1 hour machine B has to sit idle. Machine B has to sit idle. Job number 3. At what time job number 3 can enter into machine A? End of the 11th hour. How many hours it will take, sir? 2 hours it will take. 11 plus 2, 13. 11 plus 2, 13. So end of the 13th hour, it is coming out from first machine. At this stage, can I pass on this job from machine A to machine B? Answer is no. Why? Machine B is busy. Machine B is busy with the second job till the end of 19th hour. Till the end of 19th hour. Therefore, job number 3 has to wait here for another 6 more hours. That is from the end of the 13th hour to end of the 19th hour, this job has to wait here. So, at what time it will enter into the second machine, sir? At what time it will enter into the second machine? Only at the end of 19th hour. Here job is waiting, sir. Machine is not waiting. When machine is not waiting, there is no idle time on the machine. So here last column it is a dash. End of the 19th hour. End of the 19th hour. My job is entering into the second machine. Job number 3 will take how many hours? 6 hours are required from machine B. So 19 plus 6. This is a 25. At the end of 25th hour, at the end of 25th hour, this job is coming out from this machine. Now job number 4. At what time this job can enter, sir? End of the 13th hour only. End of the 13th hour only. Job number 4 can enter into machine A. Because machine A is free from job number 3 at the end of 13th hour. Job number 4 will take how many hours, sir? 5 hours. So 13 plus 5 is 18. At the end of 18th hour, 4th job is coming out from machine A. One more time, I am analyzing here. Can I pass on this job from machine A to machine B? Can I pass on job number 4 from machine A to machine B? Again, my answer is no. Why? My second machine is busy with the previous job till the end of 25th hour. With job number 3, machine B is busy till the end of 25th hour. So, it will accept job number 4 only at the end of 25th hour. So 25th hour, this job is entering into machine B, and job number 4 will take 6 hours. 25 plus 6, 31. There is no idle time on second machine. There is no idle time on second machine because this time job is waiting, sir. Machine is not waiting. Next, job number 5. It can enter into machine A at the end of 18th hour. 9 hours it will take. 18 plus 9 is equal to 27. 18 plus 9 is equal to 27. Now, again, same situation. Machine B is busy with the previous job till the end of 31st hour. Whereas, job number 5 is free from machine A at the end of 27th hour. At what time machine B can accept job 5? Only at the end of 31st hour. Therefore, at the end of 31st hour, it is entering into machine B. Job number 5 will take how many hours, sir? 4 hours only. 31 plus 4, 35. At the end of 35th hour, this job is coming out from machine B. Since there is no idle time on the machine B, it is a dash. Finally, sir, job number 6. At what time it will enter into machine A? At what time it will enter into machine A? At the end of 27th hour. Okay. Job number 6 will take how many hours? 8 hours. 8 hours. So 27 plus 8, 35. End of the 35th hour. End of the 35th hour. This job is coming out from this machine. At the same time, machine B also free from the previous job. Therefore, it will enter into machine B at the end of 35th hour. 1 hour only it will take. 35 plus 1, 36. 35 plus 1, 36. Therefore, total elapsed time is equal to 36 hours. At what time first job is entering into the machine 1, sir? 0th hour. At what time last job is coming out from machine 2, sir? 36 hours. End of 36th hour. So total elapsed time is equal to difference of these two timings. Therefore, capital T is equal to total elapsed time. Total elapsed time is equal to 36 hours. Total elapsed time is equal to 36 hours. Okay. Idle time on machine B. Idle time on machine B is equal to 8 hours. Okay, sir. Now this is the meaning of sequencing of jobs. So let us go back to the concept one more time. Sequencing models stands for what? Sequencing models stands for processing of n number of jobs on two machines when the processing order is given. One more time I am repeating the definition, sir. Sequencing models stands for what? Sequencing models stands for processing of n number of jobs on two machines. Okay. What additional information is provided to you? Time required for each job from each machine is given. Time required for each job from each machine is given. And the order is also given. What is meant by order? Each job will enter into which machine first. That is also given. Here processing order is AB. It means every job is entering into machine A first, then it will go to machine B. Then it will go to machine B. Okay, sir? This is the case, sir. Now let us see some analysis here. My machine second is idle for 8 hours. For these 8 hours also I am paying wages to the operators. If these machines are operated manually, so for 8 idle hours also you have to pay wages to the workers. Now, I want to reschedule the jobs. I want to reschedule the jobs in such a way so that total elapsed time can be minimized. Total elapsed time can be minimized. So when I minimize the total elapsed time, I can also reduce the idle time on machine B. When I reduce the idle time on machine B, I have some savings, sir. For those reduced hours, no need to pay the wages. So this is the concept of job sequencing problems. Okay. So where it is given in the material, sir? My material is as 2000 new old edition, sir. Old edition means first time 2013 when this new syllabus is printed. That time I am a visiting faculty for CMA Bhavan, so they have provided this material for me. According to mine, it is page number 2. According to page number 2.404. There may be some variation of 15 to 20 pages in the new version. In the new version, sir, some concepts, some pages are deleted. So because of this, some variation you are observing. Whoever watching my classes, you open your CMA material also. It is a job sequencing model. Look at the assumptions given. Assumptions given. 2 marks theory question, sir. 2 marks theory question. What are the assumptions? What are the assumptions for processing of n jobs on 2 machines? What are the assumptions of processing of n jobs on 2 machines? It is given in the same page number 2.404. Look at the first assumption. The processing times on various machines are independent of the order in which the jobs are to be processed. So these processing timings are independent of this order. In which order you are processing, with that the time required for each job, they are independent. Second one is time taken by different jobs is going from one machine to another machine is negligible. What does it mean actually, sir? Look at the job number 1 here. Job number 1. At what time job number 1 is free from machine A? At what time job number 1 is free from machine A? At the end of 7th hour. Now, at what time second machine is accepting this job? At the end of 7th hour only. So, the time required for a transferring of this job, that is job number 1, from machine A to machine B is negligible. Clear? So when it is free from machine A at the end of the 7th hour, at the same instance of time, this job is processed on machine B. This is the second assumption you are having. Third one, a job once started on a machine would be performed to the point of completion uninterrupted. It means, look at this, sir. When a particular job is entered into a particular machine, that is machine A, it is the sole occupant of this machine till its work is completed. You cannot process a part of this job, accept the second one, again sending the first one. It is not on a rotation basis. Once a job is entered into a particular machine, it will be in the machine till its completion is over. Next, a machine cannot process more than one job at a given point of time. It means you are assigning only one job at a time to one machine. Next, a job would start on machine A as soon as the job and the machine on which it is to be processed are both free. Look at this. At the end of the 7th hour, this machine is free from first job. Sir, I am giving explanation to the last point E. What is that point? A job would start on a machine as soon as the job and the machine on which it is to be processed are both free. What does it mean actually? At the end of the 7th hour, machine A is free from job 1. Immediately it is accepting the second one. So next job which is in the sequence is processed on the first machine as and when it is free from the previous job. Okay. That is the meaning of this one. Here also look at this. This machine B is free at the end of the 10th hour. It waited for 1 hour to accept the second job, because job number 2 cannot come out from machine A before its completion. Okay, its work is over from machine A only at the end of the 11th hour. Therefore, here second machine is waiting, even though it is free at the end of the 10th hour. Clear, sir? These are the assumptions we are having. Let's have one more time attention on this. The processing times on various machines are independent of the order in which different jobs are processed. This is the first assumption, sir. Second one, the time taken by different jobs in going from one machine to another machine is negligible. That is the time required for transferring the jobs. Transferring the jobs from machine A to machine B is negligible. Third one, a job once started on machine A would be processed to the point of completion without any interruption. A machine cannot process more than one job at a given instant, at a given point of time. It means you cannot assign 2 jobs to the same machine at the same time. A job would start on a machine as soon as the job and machine on which it is to be processed are both free. Look at this, sir. Here one more time I am giving explanation. Machine A is free from job number 2 at the end of 11th hour. So when will it accept job number 3? Immediately at the end of the 11th hour only it can accept the next job. These are the assumptions. Remember, sir, go through one more time, write on a paper 2 or 3 times, so that you can write the same points one more time in the exam. Because in our OPM paper, so far the trend, how institute has given questions, out of 60 marks OPM, only 30 marks practical problems are given and 30 marks theory questions are given. Therefore, for every chapter, you have to concentrate on the theory also. Clear, sir? This is working part, sir. No need to show it in the exam. Since it being the first question, to introduce the concept, this working part is considered by me. Okay? If it is working part of my question, then what will be the actual solution? This is the doubt you will get in your mind. Okay? So I am coming to the solution, sir. From this working, what points I observed here? Total time required for completion of these jobs are 36 hours. Out of 36 hours, machine 2 is idle for 8 hours, and for these 8 idle hours also, we paid wages to the workers. Here, I want to reschedule the jobs to minimize the total elapsed time. When I am minimizing the total elapsed time, I am also reducing the idle time on machine B. Clear? Good. Let's go to the solution. So, solution to this question. Solution. How to prepare the sequence in which I have to process these jobs. For this, there is an algorithm, sir. Algorithm means there is a process or steps you can say. First, identify the least processing time. Look at this. This is example number 29. It's given in your material also. Step by step I am explaining, sir. This is example number 29. Example number 29, page number 2.404. Example number 29, page number 404. Look at the first step. What is the first step, sir? Identify the least processing time. Identify the least processing time of these jobs. Identify the least processing time of these jobs on the 2 machines. 1 hour is the least processing time. 1 hour is the least processing time. Okay. Next, the second point. Where it lies, sir? Is it on the first machine or is it on the second machine? It is on the second machine. Since it is on the second machine, So this job is to be processed on the first machine only at the end. Okay, one more time I am repeating. If the least processing time lies on the second machine, that particular job is processed on machine A at the end. So what is the order of job number 6? Job number 6 is the last job which will enter into machine A. Job number 6 is the last job which will enter into machine A. Now eliminate this job from the picture, sir. Its order is determined. Next, from the remaining jobs, identify the least processing time. This time, least processing time is 2 hours. This time, least processing time is 2 hours. Okay, it is on the first machine. It is on the first machine. Therefore, this job is the first job which will enter into machine A. So, if least processing time is on the first one, then that is the first job which will enter into machine A. If least processing time is on the second one, that is the last job which will enter into machine A. So, job number 3 sequence also eliminated, its order is fixed. Next, from the remaining, what is the least processing time, sir? 3 hours. This 3 hours is on the second row. Since it is on the second row, this job will enter into the machine A before job 6. So J1 is the job. It is also eliminated. Next, what is the least processing time? 4 hours. Least processing time is 4 hours. But it is at 2 places, sir. Least processing time is at 2 places. One is here on the first row. Second one is here in the second row. Least processing time is at 2 places. It is on the first row as well as on the second row. Therefore, job number 2 I am writing from the left hand side and job number 5 I am writing on the right hand side. Next, which job left over, sir? Only one job, job number 4. Job number 4. Okay, this is heart of the job sequencing problems. Preparation of the sequence is heart of the problem, sir. When you do 2-3 problems, you too will get command on preparation of these jobs. Now, job, machine A, at what time it will enter and at what time it is coming out. Machine B, at what time it is entering and at what time it is out. Ideal time on machine B. Ideal time on machine B. So, job number 3 will enter first. Job number 2 will enter next. Job number 4 will enter next. Job number 5, job number 1, job number 6. This way, order is determined. Once the order is determined, it's very simple logic. It's very simple logic, sir. In and out time you have to calculate. 0th time, this job will enter into machine A. Job number 3 will take only 2 hours, sir. 0 plus 2, end of the second hour, it is coming out from machine A. Immediately it will enter into the second machine. And how many hours are required? 6 hours. So, end of the 8th hour, this job is also coming out from machine B. Look at this one more time. Which job will enter into machine A first? Job 3. How many hours are required for this job? Only 2 hours are required. So, at the end of the second hour, job number 3 is coming out from machine A. As and when it comes out from machine A, immediately it will enter into machine B. So, end of the second hour, machine B will accept this job. And how many hours are required from machine B? 6 hours are required. So, at what time this job is also coming out from machine B? End of the 8th hour. Clear? When job number 3 is processing on machine A, sir, machine B has to wait for 2 hours. Therefore, waiting time of machine 2 is equal to 2 hours. Or idle time on machine B is equal to 2 hours. Next, job number 2 is the next job. At what time it will enter? End of the second hour it will enter. End of the second hour it will enter. How many hours are required? 4 hours are required. 2 plus 4 is equal to 6. 2 plus 4 is 6. At the end of 6th hour, this job will come out from machine A. Will it enter into machine A immediately? No. Why? Machine B is busy with the previous job at the end of 8th hour only. And from the assumptions, we know only one job can be assigned to one machine, or a machine can process only one job at a time. A machine can process only one job at a time. Therefore, it cannot accept another job simultaneously. Here job is waiting. How many hours it will wait here? 2 hours it will wait. So this job is transferred to the next one at the end of 8th hour. Job number 2 will take how many hours, sir? 8 hours. 8 plus 8 is 16. End of the 16th hour, job number 2 is coming out. There is no idle time on this. This time, there is no idle time on machine B. Next, who is entering into machine A? Job 4. How many hours it will take? 5 hours. At what time this job can enter, sir? End of the 6th hour. How many hours are required? 5. So at what time it is coming out from machine 1? End of the 11th hour. Now, at this stage, can I process this job from machine A to machine B? Can I transfer this job from machine A to machine B? No. Why? Machine B is busy with previous job. So, this job, that is job number 4, will enter into machine B only end of the 16th hour. Only end of the 16th hour. Now job number 4 will take how many hours, sir? 6 hours. So 16 plus 6 is 22. There is no idle time on this. There is no idle time on this. Next, which job has to enter? 5th one. At what time? End of the 11th hour. Job 5 will take how many hours, sir? 9 hours. 11 plus 9 is equal to 20. Now, will it enter into machine B? No. At what time? Then 22nd hour only. 5th job will take how many hours? 4 hours. 22 plus 4, 26. There is no idle time. Next, who will enter, sir? Job number 1. At what time? 20th hour. How many hours are required? 7 hours. So 20 plus 7, 27. Okay. At what time this job will enter? At the end of 27th hour. But machine B is free, only machine B is free at the end of 26th hour. So here machine B is waiting 1 hour. So idle time on machine B is 1 hour. Job number 1 will take how many hours, sir? 3 hours. So 27 plus 3, 30. Last one is 6, job number 6. So 27 plus 8, 35. 35. At what time it will enter? 35th hour. Sorry, this is 27. 27 plus 8, 35. It will enter into 35. How many hours are required? 1 hour. 35 plus 1, 36. 5 hours. Idle time is 8 hours. Total elapsed time is 36 hours. Okay. Look at this problem. Even though the jobs are rescheduled here, there is no advantage. Second machine is still 8 hours idle. Total elapsed time also remains unchanged, 36 hours only. It doesn't mean that for every problem you'll get the same answer. Here it is This is the problem. In this problem only, before and after. What is before and after? Processing the jobs in the same order or rescheduling the jobs using the algorithm. Both are taking equal hours and ideal time also same. But I'll show you the variation in the next problem. Okay, sir? So this is the first problem for processing of n number of jobs on 2 machines. Okay, sir? I'm giving 2 minutes time for you to note down the solution.